Hi everyone, hope you're doing well. This is a video to go over homework number 110, your residuals homework. Please make sure you post this on Google Classroom so you get credit for it. All right, so our first question is pretty basic. You don't have to really fill anything in. I already gave you the X and the residual, and I asked you to plot the residuals. So pretty low numbers, so both the X and the Y axis I only labeled, or I went up by ones. So I just plotted all my points, 2, 2, 3, 1, 3, -1, 4, -2, 6, -3, 7, -2, 8, -1, 9, 2, 9, 0, and 10, 3. So this is what it looks like. Make sure this is labeled with, actually technically it's residual over here, but I like to write it here and here anyway. So as you can see, or at least I hope you can see, you definitely see that U pattern, which means it's no good. So using the plot, it says the fit of the line. The fit of the line is not good because there is a pattern in the residual plot. So basically, because there is a pattern, that means that it is no good. So nonlinear would be better. Okay, next page. It says a curve or pattern in the residual plot indicates a nonlinear, where random scatter would be your linear. So no good is the pattern, that's nonlinear. Good is random, that's linear. Okay, so same thing here, just looking at the pictures. This one definitely shows the U pattern. Okay, so linear regression model would not be appropriate for the data because of pattern in the residual plot. Nonlinear would be better. Here you could definitely see scatter, random scatter. So a linear regression model would be appropriate for the data because there's no pattern in the residual plot. The plots in the residual, the points in the residual plot are random and it has random scatter. So random scatter is good. All right, page 3. The curb weight of a car is the weight of the car without the line. Blah. Okay, so line of best fit. So again, you want to put this into L1, put this into L2, and you come up with your equation. I already did that. Stat 1. I had all those numbers in there, and then I pressed stat calc 4, and I got my equation. So negative 1.53. 78.62, and then you can see your correlation coefficient. It's good, but it's not the best. So that means those dots are going to be further away from creating that, perfect straight line. So it's going to be not as good. So maybe more like moderate correlation. All right, scatter plot shown below. Least squares line. That just means line of best fit. Okay, so with the residual for the car whose curb weight is 25.33. So 25.33 is this dot up here. Is it positive or negative? Now this goes back to the video that you watched. This is going to be positive because the point's above the line. So if I take this value, which looks like around 43, subtract it from here around 40, I'm going to positive 3 value. Whereas the one for 27.79, that's down here, I'm going to do the line, how'd you know? So this one would be negative because it's 30 minus, I don't know, maybe like 37, and that's going to be a -7. So positive above, negative below. Okay, so that shouldn't be too bad. And then our last page, last question. The following table displays a sample of student messages sent in a week, an hour spent studying line of best fit. All right, so we give you the X and the Y. We give you your L1 and your L2. You don't have to come up with the equation. You already have it. You want to get the predicted. Remember, the predicted comes from this equation. So what you're doing is you're going to Y equals, and you're plugging in negative 0.51x plus 17.59. And you're going to the table. Okay, I'm going to write table, Y value from table, so that you know where I got this from. All right, so as you see, if you go to 8, 8 is 13.51. I want it to the nearest integer. It says right here. So that's where they came up with the 14. So for 12, it would be 11.47, which is 11. For 20, it's going to be 7.39 or 7. And then let's check the rest. So 24, 29, and 32. So 24 was 5. 29 was 3. And then your last one, which was 32, is where they got the 1. So that's how we came up with 11 and 7. Now for the residuals, again, you're just doing your Y1 minus your Y2. Literally in the order you see, just 16 minus 14, 11 minus 11. So you have 2, 0, -2, 3, -1, and 0. All right, part C. If a student sends for 20 or text messages a week, or maybe a student sent 20 for text messages a week, what would our line predict about the number of hours a student study. All right, so you have to basically put that into your equation, right? Because it says, what would our line predict? So what would our line predict? Meaning use your equation. So if I plug the equation, text messages are X, so plug that in for 22. And when you solve 6.37, nearest answer would be 6 hours. I think it's just supposed to be sent 22 text messages in a week. That sounds better. All right, construct a residual plot of data in the space below. So again, when you do that, you're graphing the X and the residual. Okay, the X and the residual. So these numbers are pretty high. This time I counted by 2s, and these ones are pretty low. So again, I like to do every other by 1 if possible, because it spreads it out a little more, a little easier to see. Okay, so you have 8 and 2, 12 and 0. And then we have 20 and -2, 24 and 3. So we moved over a smidge, 24 and 3, 29 and -1, and then 32 and 0. So hopefully you could tell it's have a couple above, a couple below, and that would be no pattern. So does the residual plot indicate a linear or non-linear relationship? Again, this is all about linear. So you want to know if the linear fits, which it does. Residual plot indicates a linear relationship because there's no pattern in the residual plot. It has random scatter. All right, hopefully that's all makes sense. Hopefully you did well on this really super duper tough topic. Don't forget to put it into Google Classroom, post it for me so I can look at it and you can get credit. All right, have a great day. If you have any questions, please reach out to me.